Have you ever wondered how we might harness the vast energy of a star? What if our technology could tap into the power of the sun in unimaginable ways? This idea leads us to the fascinating concept of a Dyson sphere, a megastructure envisioned to surround a star and capture its energy output. The term Dyson sphere was coined by physicist Freeman Dyson in 1960, who proposed this idea to address future energy needs of civilization. Imagine a civilization so advanced they could construct a shell or a swarm of satellites to gather energy from their sun more efficiently than we do today. A Dyson sphere could capture around 100% of a star's energy, enabling technology advancements like interstellar travel or massive power systems. However, constructing such a megastructure poses immense engineering challenges, requiring materials and resources beyond anything we've harvested today. The concept also raises questions about the sustainability of resources, energy consumption, and the ecological impact on our home planet. Moreover, the search for extraterrestrial civilizations might be influenced by Dyson spheres, as their energy signature could signal advanced life. As we explore the cosmos, the idea of a Dyson sphere continues to fascinate scientists, dreamers, and science fiction enthusiasts alike. Yet the quest to create such an enormous structure is not just a sci-fi fantasy. It sparks real discussions about our future energy solutions. Are we ready for the challenge of building a Dyson sphere? The technology of tomorrow could rely on our willingness to innovate and collaborate. To understand the full implications of a Dyson sphere, we must delve deeper into its structure, types, and the potential societal transformations it may bring. Join us as we explore the fascinating details of what it would take to build a Dyson sphere and the future of energy harnessing. As we look to the stars and dream of energy solutions, the Dyson sphere stands as a beacon of what humanity might achieve with ingenuity and determination. What if we harnessed the entire energy output of our sun? A Dyson sphere could theoretically collect solar energy on a massive scale, transforming our energy landscape. Imagine a shell surrounding the sun, capturing all its energy, preventing waste and providing nearly limitless resources. But how would we build such a marvel? Constructing a Dyson sphere would require advanced materials. Current technology uses solar panels, but we need something much more durable for this scale. Materials like graphene and carbon nanotubes offer incredible strength and lightness. Could these be the future of large-scale constructions like a Dyson sphere? Energy harvesting technologies would play a huge role. Photovoltaic cells are just the beginning, but we need innovations to make them efficient enough. Transporting materials into space poses significant challenges. Rockets and transport systems must evolve to handle large-scale construction missions. As we build, we must ensure the structure maintains its integrity and safety. Advanced robotics might be the answer for precise assembly in harsh environments. Also crucial, an energy transmission system back to Earth is necessary. We could consider using lasers or microwave technology for wireless energy transport. Maintenance for such a vast structure will be complex. We'd need a fleet of drones to help monitor, repair, and maintain the Dyson sphere reliably. The sheer scale of construction cannot be underestimated. Resources for such a project may involve utilizing materials from asteroids or other celestial bodies. Moreover, a Dyson sphere would dramatically alter the dynamics of space around it. What impact would that have on neighboring planets or asteroids? Environmental concerns arise too. How would building a Dyson sphere affect our planet and the solar system's ecosystem? Despite all challenges, the excitement of possibly harnessing stellar energy is inspiring. How close can we get to making a Dyson sphere a reality? In the next segment, we will investigate the possible consequences of building a Dyson sphere and what that could mean for humanity. Constructing a Dyson sphere sounds incredible, but many engineering challenges stand in our way. Let's explore the difficulties we would face. First, we need vast amounts of material. Where will we find billions of tons of resources to build such a massive structure in space? Transporting materials from Earth or asteroids to space presents another massive challenge. How can we handle such gigantic logistics? The construction itself has to withstand extreme conditions in space. How do we protect our structures from radiation or micrometeorites? Then there's energy management. Harvesting and utilizing the vast energy from such a structure requires advanced technology we are still developing. Then we must ask, how will we assemble the Dyson sphere in the vacuum of space without gravity to help us? As we build, the engineering design must be adaptable. What if something goes wrong during construction? We need backup plans. We must consider the environmental impact. How will we ensure that building a Dyson sphere does not harm our planet or space ecosystems? Next, we need to consider the enormous cost. Funding such a venture would require unprecedented global cooperation and support. The technology we rely on has to be revolutionary, but are we ready to alter our existing progress frameworks for this colossal task? Amid these challenges, technological advancements in robotics and AI could play a crucial role. How can these technologies help us build? We also need to accept that a Dyson sphere is a long-term project. How can we maintain motivation and resources over decades? Finally, as we dream big with the Dyson sphere, we must remain grounded. What happens if we face unforeseen disasters? Despite these hurdles, the idea of harnessing energy on such a scale is fascinating. Are we ready to tackle these challenges together? Imagine a world where our energy needs are met entirely by the stars. A Dyson sphere could revolutionize how we harness energy, affecting every aspect of our lives. With almost limitless energy from a Dyson sphere, humans could finally conquer energy scarcity. What would this mean for industries across the globe? Transportation would undeniably change. Imagine spacecraft fueled by stellar energy, enabling travel to distant planets and asteroids with ease. A Dyson sphere could facilitate the development of megacities. These awe-inspiring urban centers would thrive with abundant energy and advanced technology. This abundant energy could also help mitigate climate change. Imagine using clean energy to reverse the damage done to our planet. Educational advancements would skyrocket as well. With newfound energy resources, learning and research could thrive like never before. Art and culture might flourish in this new era of energy abundance. Creators would have more resources to bring their visions to life. With all this energy, we could explore the universe further. A colony on Mars might not be just a dream, but a part of our future. However, this immense power comes with responsibilities. How would we govern and manage such technology to ensure it is used for the good of all? Ethical dilemmas might arise as we manipulate energy on such a grand scale. Would there be regulations protecting our planet and its inhabitants? Communication and collaboration among nations will be vital to manage this new energy source responsibly. How can we ensure global unity in its use? The ambitions of humanity with a Dyson sphere could stretch even further. We might dream of terraforming distant worlds, making them habitable. In this speculative future, the implications of a Dyson sphere stretch beyond energy. It challenges us to rethink our place in the universe. Our future with a Dyson sphere could reshape society as we know it. What new possibilities might arise from this monumental leap in energy?